Since we have already started studying conjugate elements and then class equation, right? So this is the study of conjugacy specifically in the symmetric group Sn. Why we are studying this Sn group specifically? Because these are some special groups. They show some special behavior, especially when you partition them in terms of conjugacy classes, right? They show a special behavior. So to start with, I have taken an example of S5, right? The symmetric group on 5 symbols, and this is one of the permutation in S5, represented by cycles. Actually, these are called cycles. You know them, right? How to form cycles from permutation. And this is another permutation from the same set, tau, right? And now I'm going to conjugate sigma by tau, and you know that the operation of conjugation is this. It means that the element sigma is conjugated by the element tau, right? The element which is sandwiched in the middle between the element and its inverse. Then you say that sigma is conjugated by element tau, right? Now what I will do, I will just put the values of these sigma and tau. This is my tau 1, 3, 5, 4, and here is my sigma 3, 2, 4, 1, 5, and now sigma inverse 1, 3, 5, 4 inverse, right? And if you write it in permutation form, then you will be writing 1, 3, the image of 3 will be 5, image of 5 will be 4, image of 4 will be 1, and 2 is mapped to 2 because 2 is absent here. And now it's complete, I think. Yeah, 5 symbols are complete, and it is 3 mapped to 2, 2 mapped to 4, and 4 mapped to 3, right? And the missing numbers are 1, 1 and 2, 2. The missing numbers are always mapped to themselves, right? So this is the rule to write a permutation from a cycle actually. Now the next is 1, 5. Sorry, extremely sorry. Actually, this was the uh, complete value of sigma. So I should write the image of 1 is 5 because image of 1 is 5, and the image of 5 is 1. This portion is due to this, and this portion is due to this, right? Because these two cycles actually were the same element, sigma, so that's why they can be represented using a same permutation, right? Okay. Now the inverse of this permutation will be the permutation which is obtained by switching these two rows. The first becomes second and second becomes first row. I will be switching these two rows. So 3, 5, 4, 1, 2, and this will be 1, 3, 5, 4, 2. This is the inverse of this tau, right? Okay, now I'm going to multiply these permutations, but this time multiplication will be done from right to left actually. What we usually do, we usually multiply them from left to right, but this will actually, they should be multiplied from right to left because these are just functions actually. F, if you are operating three functions f or g u h, then what comes first? Mridul, 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 please appear.
Yes, sir.
If you have this FOGUH, then what will be the first function which will be going to act on some number? Suppose I write here x. What is the first function which is going to act on x? H or f?
H.
Of course, H. So that's why since these permutations are nothing but they're one onto function, so they should be treated like functions. So what should be done actually? This permutation should be the first permutation which is acting on some element of that set, whatever domain you are taking, right? So that's why what I'm doing, I will multiply these permutations from right to left, and this is called a standard convention actually. Generally, few textbooks are using that multiplication from left to right, which is not absolutely correct. The correct procedure is to multiply from right to left actually, right? So now what I will be doing, I will be just writing this first permutation without any change, right? And then I will multiply these two permutations like this. See, the image of 3, the image of 3 is 1 and the image of 1 is 5, so that's why 3 is mapped to 5, right? And you can see that I am using the multiplication from right to left rather than from left to right. Is it clear to all of you that why 3 is mapped to 5? 5. We are just taking the product from right to left actually. The actual scenario, what happens when you operate composite two function fog, then g comes first, then comes f. That's why, right? The image of 5 is 3 and the image of 3 is 2, so that's why 5 maps to 2. And then image of 4 is 5, image of 5 is 1, so 4 maps to 1. Image of 1 is 4, image of 4 is 3, so 1 maps to 3. And finally 2 maps to 4. So this is due to the result of multiplication from right to left. I will mention it here. Multiply from right to left, right? This is the standard way to multiply actually, right? Okay. Now again, the image of 3 is 5 and the image of 5 is 4, so that's why 3 maps to 4. Image of 5 is 2, 2 maps to 2. Image of 4 is 1, 1 maps to 3. Image of 1 is 3 and 3 maps to 5. 2 is maps to 4 and 4 maps to 1. So this is the final permutation you have got. I think the answer is clear to all of you. Shreya and Mridul, please confirm that you got this logic. Why we are multiplying from right to left. And that's called the standard multiplication. This is how permutations are multiplied, right? Uh, is it clear to both of you?
Yes, sir.
Okay, fine. Now, we'll just write this permutation as a product of cycles actually, right? So 3 maps to 4 and 4 maps to 3. So that's why this is the first cycle. And then I will write that 1 maps to 5 and 5 maps to 2. This is the second cycle. So you can see the cycle structure. These are actually two cycles. The one is a 2 cycle and this is a 3 cycle, right? Okay. So what we see that the action of a conjugation of sigma by tau gives you a permutation of this form, and which is actually same cycle type as sigma. This is an observation. See the cycle type of sigma, because you can always write it as by switching the cycles. The you know that this is commutative. Do you know this point? The permutation product is commutative when the cycles are disjoint. Do you know this point? Okay. So now you observed that whenever you conjugated that permutation of this cycle type by any element of S5, the result is again the permutation having the same cycle type, right? So this holds for all, right? So this is an observation. The result tau belonging to S5, right? This is not just true for this tau. If you choose any tau, any cycle type, this tau was a 4 cycle actually, right? So whether tau is a 4 cycle, 3 cycle, 2 cycle, whatever cycle you choose, the result, this result will always be same. There is a output of this conjugation will always be having the same nature as the original cycle sigma, right? So that's why we can say that this conjugacy class, conjugacy class of some element sigma belonging to Sn, and this not just hold for S5. You can generalize it for Sn, right? Is uh, the set of all permutations in Sn having same cycle structure as that of sigma. So this is the final conclusion. Whatever tau you choose, right, to conjugate sigma, the always there will be the result which is always having the same cycle structure as that of sigma. So that's why we can write that the conjugacy class is denoted by C, and C, this is called the conjugacy class of sigma. We use this letter, and that is the set of the elements of the form tau sigma tau inverse such that uh, tau belongs to what? Tau belongs to S5, and this one, especially this one, I will highlight this. This will be having the same cycle structure of same cycle structure as sigma. Right? Is it clear to both of you, Shreya and Mridul?
Sir.
Okay. Right. Now we'll go to few remarks and yeah, remarks and remark number one. Remark number one tells you a shortcut method actually. Short method to compute tau sigma tau inverse. You just saw that this is a quite long method to compute the conjugation of sigma by tau, right? So for the same example, for the same choice of sigma and tau, I'll be computing this sigma tau sigma inverse, sorry, tau sigma tau inverse in just one line, right? The shortcut method is this one. This is shortcut method, and it says that for sigma, if sigma is something like this, a1, a2 dash dash a k, right? And again there is another cycle b1 b2 dash 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 br, right? So of course this will be having a finite list of elements. Both cycles will be having finite elements, right? uh, and then for any tau you choose from Sn, right? The result of the conjugation of sigma by the element tau will be equal to something like this. You just see these original cycles. What will happen? It will just give the image of these elements by the permutation tau, right? Tau b1, tau b2 dash dash tau br. You can see that I have just taken the image of these numbers by the permutation tau. So this is the final answer. You need to remember this, right? And I will be applying this shortcut method, this method, to this example, this choice of sigma and tau, right? So I will be copying this thing for sigma, this one in S5, and tau is this permutation belonging to S5. We have, by this shortcut method, we have if I compute that sigma tau sigma inverse, then that should be just see this permutation, the elements inside these cycles, and we will write just tau everywhere, tau 3, tau 2, tau 4, and then this one tau 1, tau 5. Is it clear to all of you? I have just used this formula. What is the image of
Yes.
300 tau? See here, see from here. What is the image of 300 tau?
5.
Very good, 5. What is the image of 200 tau? See here, 2 maps to what?
2 maps to 2 only, sir.
Okay, good. And 4 maps to?
4 maps to 1.
Good. And then bracket close. And 1 maps
And then
to?
1 maps to 3 and 5 maps to 4.
4. Now see the answer. The answer was this one, 1, 5, 2, 3, 4. And this is 5, 2, 1, 3, 4. Are the answers same or they are different? 3, 4 is same. You can see that both the permutations are having 3, 4. But one, it was 1, 5, 2, and here I am having 5, 2, 1. Are they same or different? Mridul?
Same only, sir.
Same only, because this is cycle. No? 5 to 1 can be written as 1, 5,
Yes, sir.
because
Yes, sir.
you know this. 3, okay. 3, 4. So now you observe that this is you can just skip this long method to find the composition of composition by conjugation actually, right? And this is a shortcut method which you can use here, right? And due to this, you just see that what is happening out here. What is tau actually doing? Tau is actually replacing the original elements of sigma by its members. Yes or no? See, because 3 was replaced by what
Yes,
is
sir.
happening. See the original permutation and see the final permutation. What is the difference between them? The 3 has been replaced by 1. Yes or no? Okay, or you can say that
Yes,
3 has
sir.
been replaced by 5. Okay, and 2 has been replaced by 2, right? So that's why it's called replacement mapping or relabeling mapping. We can see that all the members of sigma have been relabeled by the permutation tau. So that's why it's called relabeling map. Tau is called relabeling map, right? So I will write
Okay, sir.
thus the elements, thus the numbers, I shouldn't write elements, thus the numbers, the symbols, more precisely symbols. It's not necessary to write 1, 2, 3, 4, 5. Some people write X, Y, Z, P, Q. Some may write alpha, beta, gamma, A, B, C, D, E, or you may use symbols, star, hash, dollars, etc. Right? So the symbols, thus the symbols in sigma have been replaced by have been relabeled, not replaced, relabeled by tau, right? Hence tau is called relabeling map. Tau is called as relabeling map, right? That is okay. Now we'll come to the second remark. Uh, it says that let sigma 1 is this one, 1, 2, 3. Please note that this is not just true for S5. This holds for Sn actually. I have just taken an example of S5, right? So 1, 2, 3, 4, 5. This is a permutation. You can see that first permutation. And since is Mridul, can you tell some another element to which this sigma 1 is conjugate to? Hmm? Mridul? Mridul?
Yes, sir.
Any element belonging to S5 to which this sigma 1 is conjugate to. Now you know that all the elements which will be conjugate to sigma 1 will be having the same cycle structure. That's why I put the same cycle structure here. Just tell me another element randomly. It's your choice. What three elements you want to write here and what two you want to write here. It's your choice. You can write any. Suppose you write 3, 4, 1, and the rest of the elements 2 and 5 are here. Of course, these two elements are conjugate to each other because they are having the same cycle type. This
Same
is what you
cycle.
observe.
Yes.
This is what is special in SN. That's why we are studying this SN. In SN, the elements which are having the same cycle type belong to the same conjugacy class. That's it, right?
Right, sir.
Okay, okay, so these are the two elements which are conjugate to each other. Conjugate means that is there exists some tau belonging to S5 such that sigma 2 can be obtained by the conjugation of sigma 1 by element tau. This is what we mean by when we say that they are conjugate to each other. Are you getting my point? Right? Okay. So my question is what is that tau? Right? What is the tau? How will you give that tau? Right? Uh, Here tau is given by now this is very important. What is that tau? What is that tau which is actually giving you sigma 2 from sigma 1 by the action of conjugation of tau with sigma 1, right? So we want to know that tau. Just like here, we were given that tau, we were given sigma 1 and we obtained sigma 2. But this time we know sigma 1, we know sigma 2, but my question is what is the tau which will be converting that sigma 1 into that sigma 2 by the action of conjugation, right? So here's the simple answer for that. The answer is this one, is given by defining defining uh, tau. Now, Mridul, what do you want, Mridul? Mridul, you
Yes,
want
sir.
that you want that tau relabels one, 1, 2, 3. You want this that one relabels to 3. Yes or no?
Yes, sir.
One should be okay. So you want that one should be mapped to 3 by tau. This is
Tau
called
1 is
relabel.
equals to 3. Yes, sir.
Okay, and tau 2 should
Tau
be
2
equal to,
is 4.
and tau 3 1,
Yes, sir. Tau 4
tau
2 and tau 5
and tau
5 only.
5 5. So this is how tau can be defined. That's it. This is simple, right? Now you can write tau in cycle form or whatever form you will like. 1 maps to 3, 2 maps to 4, 3 maps to 1, and 4 maps to 2. Now 5 maps to 5. In cycle form, you can write it as 1, 3, and 2, 4, and 5 is mapped to itself. And you know that whenever there's a symbol which is right alone in this cycle form, then that is dropped, right? So this is equivalent to 1, 3, 2, 5, because this behaves as an identity permutation. You know this point, right? So this is your tau. Now coming to the third remark, right? No, there is no remark now, right? Should I make it conjugation in SN was the topic? Yeah, I can. Okay, I should make that different topic actually, not as a remark. Title will be different, and I will write that conjugacy classes in S3, right? Conjugacy in S3, and here I am especially focusing on conjugacy classes actually in S3, right? Okay, So specifically, S3 is having actually only how many elements does S3 has? Madhu? Madhu?
Sir, please repeat this.
How many elements does S3 has?
6.
6. So let me take some arbitrary set on three symbols. We should write little a, little b, little c, right? Or you can write a, b, c, or a star hash dollar, right? For a, you know that S3 contains how many permutations? You said that 3 factorial equal to
6.
6
Yes, sir.
permutation. Okay, that's fine. Now what we want to do, we want to classify this S3, which is having a total of 6 elements, into small subsets, and those subsets will be just due to the conjugacy classes of different elements inside S3. And since you know that different cycle structures in S3 will be producing different conjugacy classes. So if you want to know about the conjugacy classes in S3, you should be focusing on finding the different cycle structures inside S3, right? So let me write that point. Um, the cycle structures in S3, or I should write of the elements of S3, structures of the elements of S3 are Mridul, what are the different types of
Yes, sir.
cycles you see? What are the different types of cycles you see in S3? Hmm? Type. Do you see some cycles of this type? ABC, this type? Three cycle, you call it three cycle.
Yes, sir. 3 types की होती है sir.
हाँ, थ्री टाइप्स की होती है. तो ये कितनी होती है, ये वाली, ये कितनी होती होंगी? टोटल कितनी होती हैं?
Sir, 1.
याद है?
ये तो 1.
वन नहीं होती, टू. वन नहीं होती, टू होती है. एक होती है एबीसी, एक होती है एसीबी. लास्ट की दो होती हैं. दो होती हैं ये.
Okay, sir.
दो होती. टू साइकिल्स और टू परम्यूटेशंस, राइट? पता है कौन कौन सी होती हैं? एक तो ये होती है एबीसी, और एक होती है ए सी बी, राइट? नेक्स्ट इज टाइप ए बी. ये कितनी होती हैं इस टाइप की, ए बी टाइप की? याद है?
Sir, ये
थ्री
भी 2.
होती हैं. टू नहीं होती है, थ्री होती हैं. सोचो ना, तीन सिंबल्स हैं आपके पास. There are three symbols.
Sorry,
One
sir.
is AB.
Yes, sir. Got it,
एक
sir.
हो सकती है AC, और एक हो सकती है
BC.
BC.
Yes, sir.
तीन हो सकती है.
Sorry, sir.
तीनों. ठीक है. और ये वाली अब तो बची नहीं कुछ. अब तो ये वाली बची, टाइप अकेली वाली, ऐसी वाली.
Yes, sir. ये होती है एक.
ये तो एक ही होती है. आइडेंटिटी एक ही तो होती है. सिंगल होता है जिसमें होती है, मतलब एक सिंगल ही होती है. वन परम्यूटेशन आइडेंटिटी, दैट इज E, राइट? तो कितनी हो गई?
Yes, sir.
3 प्लस 2, 3 प्लस
Total
2 प्लस
6,
1,
sir.
6 हो गई ना? 6 हो गई. बस ये ध्यान रखना कि 6 आपको गिन लेनी है, कोई छूटनी नहीं चाहिए, राइट? ओके.
Yes, sir.
देयरफॉर आप ध्यान से देखना. कॉन्जुगेसी क्लासेस, कॉन्जुगेसी क्लासेस आर, पहली वाली वो जिनके एलिमेंट इस टाइप के होते हैं, उनके होंगी वो कॉन्जुगेसी क्लास. उसका ऑर्डर कितना आएगा? कितनी है उसमें टोटल? दो, टू, राइट? conjugacy classes conjugacy classes of the permutations of the type this, those are actually 3 in number, right or wrong? Okay. And conjugacy classes having that's the trivial, I will not write that conjugacy class. It is actually center. This will belong to the center of the group, yes or no? ये center को belong करेगा, तो conjugacy class नहीं लिख रहा मैं उसमें, ठीक है?
Okay, sir.
हाँ, तो हम कह सकते हैं कि center of S3 will be having just this one permutation, the identity permutation 1. So this is it. Now can you write the class equation? Thus class equation of S3 is, मृदुल क्लास इक्वेशन लिख सकते हो S3 की? S3, the order of group S3 is equal to the order of the center plus the sum of the conjugacy classes, यही था ना?
Yes, sir.
हाँ, प्लस सम ऑफ द कॉन्जुगेसी क्लासेस. तो सम भी समेशन लगाने की जरूरत नहीं. समेशन क्या लगाना है, इनको ऐसे ब्रैकेट पे लिख देते हैं ऐसे करके, सी ए बी सी plus size of the conjugacy class of the type this. So that gives you this is 6, this is 1, this was कितना था? 2.
2 and 3.
अब आप जोड़ के देख रहे हो 3 + 2 + 1 6. सही है, बिल्कुल है क्लास इक्वेशन. एवरी नंबर इज
Yes, sir.
डिवाइडिंग दिस नंबर. 2 divides 3, 3 divides 6. Yes or no?
Yes, sir.
So this is the class equation of S3. ऐसे निकाली जाती है क्लास इक्वेशन किसी परम्यूटेशन वाले ग्रुप की, काउंट करके निकाली जाती है. अभी तक कल तक आपने ऐसे नहीं निकाली थी. कल तक आप दूसरे लॉजिक से निकाल रहे थे, डिवाइजर्स निकाल के निकाल रहे थे, राइट? देखिएगा मैं
Yes,
दिखा
sir.
देता हूँ. ऐसे निकाले थे, डिवाइजर करके निकाला था. इनकी नहीं निकाली जाती है. इनकी एसएन की एसएन की क्लास इक्वेशन काउंट करके निकाली जाती है, मैनुअली काउंट करके, जैसे मैंने काउंट किया. अभी आपने S3 का किया, अब हम S4 का कर लेते हैं, ठीक है? कोई प्रॉब्लम है तो बताइए,
Yes, sir.
पूछ लीजिए.
No, sir. No problem.
ठीक है. नाउ कम्स द conjugacy classes in S किसकी बताएं आपको? S5 की बता देते हैं. 4 में स्किप करता हूँ, S5 तो और भी बड़ा होता है. S5 में कितने एलिमेंट्स होंगे? S5 में तो ज़्यादा होंगे, 5 फैक्टोरियल 120. तो मुश्किल वाला गिन लेते हैं. S4 तो आप बीच का तो कर ही लेंगे आप, ठीक है? ओके, सो S5 के लिए ऑफ कोर्स योर सेट A विल बी, सॉरी, A set will be for capital A is your set, right? And set will be having 5 elements: A, B, C, D, E. Of course, this is a set, so I have to use a comma separating those elements, right? S5, the order of S5 is equal to 5 factorial, and that's equal to 120, right? Now the possible cycle structures. Possible cycle structures in S5 are, this is important, possible cycle. Mridul, tell me the first cycle structure that S5 can have. किस टाइप का होगा? 5 एलिमेंट वाला, 4 एलिमेंट वाला, कुछ इस तरीके का. मृदुल
Yes, sir.
बताओ किस टाइप के एलिमेंट होंगे? ए
Sir, 4 वाले?
टाइप, हाँ 4 वाले होंगे. चलो 4 वाले से शुरू करें या 5 वाले से शुरू करते हैं, जिनमें पूरे के पूरे होंगे. ए
Okay, sir.
बी सी डी ई, 5 का 5. कितने होंगे ऐसे टोटल? गिन सकते हो? इसको गिनने के लिए आपको थोड़ी कॉम्बिनेट्रिक्स आनी चाहिए, परमुटेशन कॉम्बिनेशन यू हैव स्टडीड इन क्लास 11th एक्चुअली। सी, पहले मैं आपको बता दूं, पहले बेसिक बात सुनिएगा। अगर आपके पास फाइव फाइव यू हैव फाइव पीपल, राइट, एंड आपको क्या करना है, यू हैव टू लेट देम स्टैंड इन अ क्यू, एक लंबी लाइन में उनको खड़ा करना है। हाउ मेनी अरेंजमेंट्स विल बी देयर? 5 फैक्टोरियल, यू नो दिस पॉइंट, राइट? But if you are going to arrange them in a sitting around a dining table, circular dining table, right? Then the formula is n minus 1 whole factorial. It means that then one element is taken as the fixed element. So that's why if you are having a 5 people and they are going to dine and they are going to sit around a dining table, circular dining table, then there will be a total of 5 minus 1 factorial, that is 4 factorial permutations. So there is a standard formula. Whenever you are going to arrange n things in a line, straight line, then the permutations are n factorial. But whenever you are going to arrange them in a circular or closed loop, right? Cycle, you call it cycle, closed loop, right? Around a circle, then the answer is n minus 1 factorial. I hope you know this. You remember this point from permutation and combination. You have done it in class 11th, right? So these are actually permutations, and these permutations are called cycles. This is a cycle actually, right? It means that after A comes B, after B comes C, after C comes D, after D comes E, and after E again comes A. So that's why it's a cycle. Cycle is something like a circular table, right? So how many elements are there? How many elements are there? 5 elements. And if you want that five symbols to be arranged in a cycle, then the number of ways are actually 4 factorial permutations. Are you getting my point, Mridul?
सर आप दोबारा ये वाला बता सकते हैं प्लीज?
मैंने कहा कि जब जब किन्हीं ऑब्जेक्ट्स को एक लाइन में खड़ा करना हो, तो कितने तरीके होते हैं उनको अरेंज करने के? अगर एक लाइन में अरेंज करना है एन ऑब्जेक्ट्स को, how many permutations are there? Permutations का मतलब number of ways out, ways in which you can arrange them. n factorial, ये तो मालूम है आपको? नहीं मालूम है? फैक्टोरियल वाला
एनपी,
फंडा पता है?
यस सर, एनपीएन।
npn, you call it
यस,
npn, good.
यस सर।
npn और n, अगर आप npn को सॉल्व करेंगे that will be n factorial,
तब
right?
भी यस सर, एन फैक्टोरियल होगी।
ठीक है। तो इन शॉर्ट में कह देते हैं कि अगर n ऑब्जेक्ट्स को अरेंज करना हो तो नंबर ऑफ वेज आर n फैक्टोरियल। बट अगर उन्हीं ऑन n ऑब्जेक्ट्स को सर्कुलर टेबल के अराउंड अरेंज करना हो, सर्कुलर टेबल का मतलब डाइनिंग टेबल होती है, जैसे डाइनिंग टेबल में एक तरीके से मालूम नहीं चलता कि व्हाट इज द स्टार्टिंग पर्सन एंड हु इज द एंड लास्ट पर्सन। आप कह नहीं सकते कि कौन सा पहला है कौन सा आखिरी है जब कोई सर्कुलर सीटिंग अरेंजमेंट में बैठता है। तो उस केस में जो नंबर ऑफ परम्यूटेशन हो जाती है वो जाती है n माइनस 1 होल फैक्टोरियल, एक कम हो जाता है, एक कम नंबर का फैक्टोरियल लेना पड़ता है। और यहाँ पे भी मैं ऐसा ही कर रहा हूँ। एक्चुअली देयर आर 5 सिंबल्स, right, and those 5 symbols are to be arranged in a cycle, and cycle is a kind of circular dining table, right? That's why that formula is used, 5 minus 1 factorial. Now it's okay?
यस सर।
Now it's okay, then so काउंटिंग करनी है ना, काउंटिंग करते हुए ध्यान रखना कुछ मिस नहीं होना चाहिए, ठीक है? चलिए दूसरा साइकिल टाइप देखते हैं। सेकंड साइकिल टाइप क्या हो सकता है, बोलिए? क्या ऐसा हो सकता है? ए बी सी डी, यस, having only 4
यस सर।
elements, yes, okay. How many permutations will be there? How many permutations? How many numbers are these numbers? These are 4 numbers, right? And these are
यस
any
सर।
4 symbols. These are any 4 symbols, and those are chosen from those total of 5 symbols. So first you have to choose 4 symbols out of 5 symbols. So this is a kind of selection you are going to make in your mind. I am going to choose these 4 particular symbols. I will be leaving one symbol. So actually you are choosing, you are not arranging. You are choosing and then you are arranging. So after you choose 4 symbols and then you are going to arrange them in a circular arrangement, then the number of ways will be 3 factorial. Are you getting this point? Why this is multiplied with 3 factorial? Mridul?
यस सर।
Okay, right. So this is just due to the circular arrangement of those selected 4 objects. First, you have to make a selection of 4 symbols out of 5 symbols. That can be done in 5C4 ways. And then out of those selected 4 elements, you have to arrange them in a circular table. Circular table because it's a cycle. That's why I'm always talking about circular table. Okay, so that can be done in 3 factorial ways. So the total number of permutations at 30, right? Now, type A, B, C, of course, right? This is also possible because D and E will be written like this, and these are treated as identity permutation. So that's why I am not writing them. There is no point to write them. This is a third category of cycle structure you may have in S5, right? Now, Mridul, tell me how many numbers are these numbers? How many cycles are of this form? ये मैंने आपके ऊपर छोड़ा, बताइए. Same logic, ऊपर वाला logic बताइए, मृदुल. Please be
Sir,
fast.
5C3 into
Very good.
2 factorial.
Good. And the answer will be 5 for 20, I think 20. Yeah. 10 into 2, that's 20. Right. Now D. And this is now type A, B, 2 cycles, right? Because C, D, and E will be treated as identity, so I'm not writing them actually, right? So how many of these will be in number? This will be 5C2 multiplied with 1 factorial, and that gives you 10 actually, right? Now, there are another cycles which are actually product of 2 cycles. Nadul, am I right? Is it possible that you have a cycle type of this form A, B, C, and then you have D, E in a separate cycle? Is it possible of this category is possible? Yes or no?
Yes, sir.
Okay, tell me another category. One is left. Type A, B, and here you have C, D, and alone you have E, and that's why this E is generally uh, taken as an identity permutation. So these are possible. I think no more than this. अगर कोई और भी possible है तो please मुझे रोक लीजिए. कुछ और भी possible है. If you are considering like something like A, B, and then C, D, E, then this is similar to this one due to the commutativity. You know that these two are same things actually,
Yes,
right? So
sir.
we are not going to overcount these permutations. This is not taken. Okay, now this is very important. ये बताइएगा गिन के कितनी होंगी. Please pay attention. In how many ways you can choose 3 symbols from 5 symbols? For this, it will be 5C3, and then out of 3 chosen symbols, you have to arrange them in circular arrangement, and that can be done in 2 factorial ways. And I'm putting a bracket here, right? And for this, you have to choose. You have actually no option to choose. You have only 2 objects. You have to choose both of them because 3 has already been chosen, right? And then you are going to arrange them in 1 factorial way. So this is the complete list you can have. Is it clear to all of you? ये समझ में आ गया आपको? This is for this one. For this one, this is the explanation. Am I right? Is it clear, Mridul?
Yes, sir.
Okay, fine. So the answer of this thing 5C3 is 10. 10 into 2, 10 multiplied with 2, and this is just 1 into 1, so that gives you 20, right? Okay. Now last, this is important. मृदुल इसके लिए explanation बताइए. 5C
5C2
हाँ,
into 1 factorial plus
into multiply.
multiply, sir, ये भी
हाँ, multiply तो आता
into
है. 2C2 into 1 factorial.
2C2 into 1
1.
factorial.
ठीक है. तो लेकिन इसको डिवाइड करना पड़ेगा पूरे को 2 से. ये भी प्रॉब्लम है. मालूम है क्यों? इस पूरे को
यस
टू
सर,
से
इसका
डिवाइड कर।
कुछ नंबर ऑफ जितने हम
एक्चुअली में जब आपने ये लिखा, व्हेन यू हैव गिवन एक्सप्लेनेशन फॉर दिस, इट विल इंक्लूड परम्यूटेशन ऑफ द टाइप सी डी आल्सो। मतलब ये हो सकता है, आपने कहा था ना 5 में से यू आर गोइंग टू चूज एनी 2 सिंबल्स फ्रॉम 5, so maybe you are going to choose C D. Of course this is included in this calculation, right? But that will
यस
be
सर,
kind of overcount. बट ये तो ओवर काउंटिंग हो जाएगी क्योंकि सीडी तो पीछे भी गिन रहे हैं आप, राइट? तो इसीलिए 2 से डिवाइड कर रहे हैं, हर चीज दो बार गिन गिन ली गई है, तो दैट्स व्हाई यू आर गोइंग टू डिवाइड बाय 2, राइट? So the
यस सर,
answer
गॉट
is
इट
this
सर।
time. Hmm. So the answer this time will be how much? I think 10. Yeah, 10 into, no, not 10. 5C2 is 5 into for 20, 10. Yeah, something is wrong there. It's 3C, 5C2. It's 3C2 actually. Sorry, 3C2. Now it's correct. 10
यस
into,
सर, बाकी 3 में से 2 चूज करने होते हैं ना वाले।
हाँ, that comes out to be 15 actually. Yes, 15, right? You should know the explanation about this division because we are not going to overcount something, right? So I will write that here. Divide by 2 to um, avoid double counting. Included in 5C2 into 1 factorial, right? So I have just written everything here. Why this is over counting or double counting? Because this is 5C2 means you're going to choose 2 symbols out of 5, and sometime you will choose AB, and sometime you may choose the same pair which you have written here actually. So that will be kind of double counting because CD times AB is actually equal to AB C D, right? So this is the reason why we are actually dividing by 2, right? Okay. Now, can we count them? How, if we count them, 30 plus 20, 50, and 50 plus 10 is 60, 60, 70, 80, 80, 80 and 95, 99 and 119. Yes, 119 is the total, but you need 120, so one is still left, and that is, I think, the identity permutation. Yes, Vidul, the one is still left, E. So I will write the
आइडेंटिटी
type.
परम्यूटेशन सर।
Okay, that's identity permutation. Type this. This is just one permutation, right? One
सर
permutation, that is the identity, right? Now I can comfortably write the class equation of, first I will write the conjugacy classes, right? And then I will write the class equation. Conjugacy classes. I'm actually writing the size of conjugacy classes, not conjugacy. So size of conjugacy classes, right? Okay, so first is
यस
this
सर।
one C, and if I write A, B, C, D, E, these are actually 24 in number, right? And then C, A, B, C, D, these are 30 in number, and then C, A, B, C, these are 20 in number, C, A, B, these are 10 in number, and this is also equal to C, A, B, C, D, E, that is also 20, and the last is C, A, B, C, D, and these are 15 in number, right? So the class equation I can write now, the class equation, class equation of S5, and now you can see that uh, S5, that is 120, is equal to the size of the center is 1, and then I will write the numbers in ascending order. I will start with 10 plus 15 plus 20 plus 20 plus 24, right? And this is just due to this fact that size of S3 is equal to size of the center plus plus sum of the sizes of conjugacy classes, sum of sizes of distinct conjugacy classes. This was topic, right? Conjugacy in SN. So, and this is general for all. I mean, this is the general method to find the conjugacy classes, or then hence the class equation of all groups of SN. Whatever is the value of n, no matter whatever is the value of n, we will just follow this method.